This is a partial explanation for a solution for the fourth problem on the homework. The objective here is to determine the unstretched length, determine the stretching, the delta S, for each of these springs that's holding up this 20 kilogram package. In addition to the two springs, which are on OA and OB, OA runs along the negative x-axis and OB runs along the negative x-axis and OA along the negative y-axis. There's a cable from the origin up to point C. And in trying to solve this problem, one of the difficulties would be to determine the location of point C, the coordinates of point C, because there's a force along C that's also opposing the weight, which is 196, of this package. And in determining the unstretched lengths, which are only on the x and the y axis, we need to get at the forces first in the z direction because we have this known here. Now, of course, we have to use the equations for equilibrium, and it's obvious that we're going to focus on the origin because all of the cables are connected at that point. So let's get right at it. We will eventually get to the equilibrium equation. So the plan of action would be to write the sum of the forces in the x, sum of the forces in the y, and the sum of the forces in the z all equal to 0. Those are the equations that we are focusing on. But of course we know one of the forces in the z. And then from those equations of equilibrium, we will be able to get to the forces that are on these springs. And once we know the forces on the springs, we take advantage of Hooke's law, where F is equal to K, the spring constant, times the stretching, and solve for delta S. That's the point that you need to keep in mind. This is what we're looking for, delta S. So, since we already know this weight, which is the tension on this line, let's focus on FOC. But FOC as a force is equal to its magnitude, which we don't know, times the unit vector along that line, OC. The coordinates of C are discerned from the diagram. We see that C, if we look at this diagram down on the XY plane, is 6 from the X, so 6 in the positive X, 4 in the positive Y, and 12 up from the origin, 12. You can see there the coordinates of C then would be 6 meters, 4 meters, 12 meters. So the unit vector then would be 6i plus 4i plus 6i plus 4j plus 12k hat over the square root of 6 squared plus 4 squared plus 12 squared. So FOC then would be the magnitude of FOC times this unit vector. And of course, the square root of 6 squared plus 4 squared plus 12 squared is 14. And so we could eventually write FOC as 3 over 7, that's 6 over 14, times that magnitude in the x direction, plus 2 over 7 times that magnitude FOC in the y direction, plus 6 over 7 times the magnitude FOC in the z direction. Okay. We also know that there's a force along the spring from O to A. And we can write that as FOA is equal to the negative FOA magnitude in the negative y direction. We write that as negative J. FOB, same thing. but it's magnitude FOB, force along this line OB, in the negative x direction. Then we apply the equation of equilibrium. So we can write in the x direction the x component of FOC, which is that 3/7, minus FOB, that's in the x direction, negative x direction, I hat, plus 2/7, the y component of FOC, minus FOA. See, FOA is in the negative y direction, plus 6/7, minus the weight of the package, which is 196. You see, those equations, we can write them individually as in terms of the sum of the forces in the x equals 0, the sum of the forces in the y equals 0, and the sum of the forces in the z equal to 0, or we can just write them out as a vector equation. Sum of the forces in terms of their vector nature still must be equal to 0. So that's what we've written here. But I could focus in on, let's say, that z component, that z coordinate, solve for FOC. And once we solve that equation for FOC, we can now go back and get the stretching. Because from that, from solving FOC in this term, we can now substitute FOC here to get FOA and FOC here to get FOB. And then apply the spring force. Force is equal to K delta S in each of these directions. The Y direction to get the stretching on this spring, and the X direction to get the stretching on that spring. That would be your plan of attack. This should serve as a hint, and I will leave it for you to go here and solve for the forces FOA, FOB, and then use the spring equation or Hooke's law equation to find the stretching. Okay?